The second technique we are going to see. Today we have constructed locus with closed views, and we have taken the rules which is a straight point. That is like the yesterday we have discussed that is the open loop transform function g of s is equal to just k divided by s into s plus 3 into s plus 4. Okay, so when we are equating the denominator of poles, what we get? The poles are 0, minus 2 and 4, which is in the real axis. Okay, and there is no zeros. This is a basic type which we have discussed yesterday. Today, what we are going to do, we are going to construct the locus. This is following procedure, but the system has a zeros as well as having a complex poles. So we have to write the problem will be like this. Right now, sketch the locus. Sketch the locus for the open loop transfer function. Sketch the locus for the open loop transfer function. G of s is equal to k into s plus 9 divided by s square. K into s plus 9 divided by s into x square plus 4s plus 11. So this is our open loop transfer function. G of s is equal to k into s plus 9 divided by s into x square plus 4s plus 11. It is given as a quotient. Further, what we have to do, we have to construct the root locus. Okay. So we know that there is a input and here is our system. Our system will be saying the open loop it is as g of s, and here will be the output, and if the system contains feedback, there will be a block that is h of s, and how will we write the closed loop transfer function? Closed loop transfer function will be as g of s divided by 1 plus g of s h of s. This is the formula which you have known, and by using this also you are going to find it. Okay. First, initially by seeing the quotient, what is the first step? Step 1. This is the basic thing we have to do for all the systems. Okay. And then first from the quotient, what we have to do from the first step? What is the first step? Finding zeros and poles. So first step, find zeros and poles. Okay. So to find zeros and poles, what we have to do? The first step, that is when numerator is equal to 0, what will be getting? We will get the zeros. So numerator what is there? K into s plus 9. If we are equal to 0, we will be getting s plus 9 equal to 0. That is s is equal to minus 9. This is our 0. Okay, number of zeros how much here? 1. So number of zeros is 1. So the 1 zero is what? Minus 9. Clear? Next for poles, what we have to do? We have to equate the denominator into 0. So when we are equating the denominator into 0, what is our denominator there? S into s square plus 4s plus 11. When we are equating into 0, we will be getting first straight away we will equate that s is equal to 0, and the second term is s square plus 4s plus 11 to be equated to 0. That is s square plus 4s plus 11 equal to 0. We can solve this equation by using the formula minus 3 plus or minus this mathematical formula b square minus 4ac divided by 2a. But if you don't need to get those much of time there. Okay, just take the calculator in your board, go for the equation. The calculator in mode, go for the equation, and here we just have the one equation, right? So what is the degree of equation here? 2 s square. The degree of equation degree is here 2 then. Okay, in mode equation. That's now first it is coming as unknowns 2 3, right? You press once again the right hand side arrow. So it is degree is right. Mode equation. First the display is unknown 2 3. You are pressing the right arrow again. It is displayed as degree is 2 3, right? Here how much for the degree? S square. So degree Let us S1 x1 as
minus 2.
x1 as minus 2. When you are pressing shift equal to again. Shift press shift equal. It is displayed as
2.64.
that is plus in plus right. There is no minus. So plus 2.64. There is a right there. So it is an imaginary. Okay. Press it again. You will be getting x2. Since it is degree 2, we will be getting two numbers. Okay. So let us minus 2. Again press same shift equal. That is minus 2.649. Okay. So what is our goals? Now solving this equation, what we have achieved? That is the first. We can say that yes, right? The what was degree of x is equal to what? Minus 2 plus 2.645. Clear? The next test is what? Since it is degree 2, we are going to be getting 2s. That's all right. One is minus 2 plus 2.648 and other one is minus 2 minus 2.649. Okay. And now, what are our goals then? Our goals are now. What are the goals now? First, the goal is 0. Since our goal first what we have done is we have already equated into 0. So on solving this equation using the calculator, with the following procedure, we have learned that s is equal to equation that is 2 times, that is s is equal to minus 2 plus 2.6, and that is s is equal to minus 2 minus 2.643. That is, so first goal is 0, and what is the second goal? Minus 2 plus 2.645. And what is the next thing? Minus 2 minus 2.645. Okay, now we are clear with this. So what is the number of poles here? So number of poles is 3. Number of poles is 3. So we will be thinking that P is equal to number of poles, that is 3. Number of poles is 1. Okay, yesterday I told you that to mark the poles in your graph. Now take your graph sheet and it is a S-plane graph sheet, and of course you have to write the scale, that is 1 centimeter is equal to 1 unit, and all these things you will know. And what is our x-axis will be sigma, and what is our y-axis? This imaginary axis, so that is plus j omega, and in the denominator is minus j omega. Okay, and it is 1 centimeter. So 1 centimeter is 1 unit is 1, 2, 3, 4. It goes on like this. What is our zeros here? What is our zero here? Minus 9. So in the real axis, it goes up to where? Up to you can go up to minus 10. Okay, so that is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 7, minus 8, minus 9. You can drop to minus 10, minus 11, 12, okay. Just you have to calculate. Just move your axis center, this origin pole towards somewhat, not don't draw that in the center of the graph. Just towards the right hand side. Okay. If this is your graph sheet means you can draw a little bit shifting over the somewhat right, so that you will be reaching up to minus 12 or minus 11, which is better. Okay. So don't take that center origin as in the center of the graph sheet. Okay, just shift somewhat right. Clear with this? So now, can we mark the poles here? How should we mark the poles? The pole should be marked with a cross mark. Okay, so the pole should be marked in a cross mark. How to mark the zeros? The zero should be marked with just a small zero. Okay, so what are the poles here? Poles are first 0. Okay, so here it is also minus j, minus 2j, minus 3j. Sorry, plus right. It's upwards towards it is plus j plus j plus 3j. Here it is minus j, minus 2j, minus 3j. It is in the negative side of the imaginary axis. Here up to this, and now what are you going to mark the poles? First of all, I have marked it remains as 0. I just made the cross mark over there since it is a representation of code. Next, what is that? Minus 2 plus 2.64. Okay. What is minus 2 here? Oh, this side. Okay. Minus 2. What it is plus 2.0 axis? The imaginary axis plus is here, right? So if it is minus 2 I means over here minus 2.6, right? So in the sixth line, okay, from minus 2 to the sixth line, and from minus 2 to over here. This point is your minus 2 plus 2.68. Clear? So that is your minus 2 plus 2.64 j, or you can write it as I. Both I and j or both can be considered as imaginary axis. And now, how we should mark the minus 2.68? Straight opposite. That is minus 2 here. Minus 2.6 will be from sixth line from the point minus 2 0, right? So this point, since it is whole way across, we are making it cross mark. Okay. So this point is what? Minus 2 minus 2.64. Okay. Now we have marked the poles. Next, what we have to do? We have to mark the zeros. The representation of 0. What is the 0 here? 0 is minus 9, which is in the real axis. That is no item, so it will be in the real axis negative side. Let us go up here. Just made a mark of 0 at the point minus 9. Now this is your, that is all the first step. Finding of poles and zeros when you have to mark it in the graph like this. Okay. And next, what is the second step?
Root locus of real axis.
You have to find where the root locus exists, right? Find root locus on. So, what do you have to do here? Root locus on where?
Real axis.
Real axis. Root locus on where? Only the real axis. Which means I am not going to consider the poles which is present in the imaginary axis. For example, what I am looking here, I will tell you that root locus on real axis. To find out what we have to consider, we have to consider the test point. Okay, just take a point. Okay, that assume it as a test point. By using this, you are going to find out where the root locus will lie down. Okay, now the test point. What is the condition? If the test point, if I am watching from this side, okay, so if the test point after the test point, if there is odd means odd number of poles and zeros. If there is odd number of both poles and zeros, mark my words, odd number of both poles and zeros. Okay, so after the test point, if there is odd number of poles and zeros, then the number locus exists. Okay, if after the test point, if I am having even number of poles and zeros, then the root locus will be existing. Okay, and now what is the point here? From the root locus, my point was of 0, and here it is minus 2 plus 2.64j, and here it is minus 2 minus 2.64j. Where I am going to check the root locus only on the real axis. I am not going to consider this and this for the root locus existing. Okay, just 0 after the where the root slides. Sorry, where the 0 slides minus 9. Okay, now I am going to place a test point. Okay, so if I place a test point over here, if I am placing test point over here, I am watching from this side. How many number of poles there? 1. Okay, if I place a test point over here, means how many numbers of poles there? 1. If I place a test point over here, at the end of this minus 9, how many number of poles there? 1. So if I am placing test point after here, I mean over this side, how many number of poles and zeros are there? 1 0 is there and 1 pole is there. Okay, what do you want? It will be odd. There is based on the odd number of poles as well as zeros. Even number of poles as well as zeros. So when I am seeing from this way, if I Okay, so you don't need to just leave that line as it is. Okay, where the root locus lies? Root locus lies only between these points. Okay, that is from 0 to minus 3. Just start that alone. Okay, so in between one another, minus 1, minus 2, minus 3, up to minus 9 point is there. The root locus lies between 0 to minus 3. This is the step 2. Okay, and next, what do you have to do with
Find the angle of first approach and centroid.
step 3? Okay, step 3, what do you have to find out? Find the asymptotes
And centroid.
asymptotes and centroid. So, what is the asymptotes? Asymptotes is a straight line. Okay, where this straight line is going to start. For that, we need a point. So, straight line has to start means it should start from a point, right? That point is said to be centroid. Okay, so in asymptotes means this is a straight line. I am having a point. When I found out the centroid, if I found the centroid, I will be having a point. So I can able to draw a line. But at what angle should I draw? Okay. For that, what you have to know? You have to find out the angle of asymptotes. Asymptotes is just a straight line. Okay. So where the straight line is going to start? For that, what do you want? The point of centroid. So centroid is the point where asymptote starts. Okay. So now the asymptotes will start from a point. But at what angle? That we have to find out by using the angle of asymptotes formula. Okay, what is the angle of asymptotes formula?
180
So angle of asymptotes is equal to 180 degree into 2q plus 1 divided by p minus z. Okay, copy up to this. Now listen. So this is for find out the angle of asymptotes. We know the formula that is 180 into 2q plus 1 divided by p minus z. So what it is a graph? We know that p is number of poles and z is number of zeros and we know that. Okay. And what is the third unknown there? Q. Okay. To find out q, what is the formula? Q is generally this is the whole number from 0 1 up to where p minus z minus 1. Okay, so for q is equal to 0 comma 1, p is what? 3. 0 is what? 1 minus 1. P minus minus 1, what is it?
1.
1. So q will be 0 and 1 alone. Okay, then no next one, next one. So now substitute q is equal to 0 and p is equal to 3, z is equal to 1. Substitute the angles. Angle of asymptotes formula. How it will become 180 into when q is equal to 0, what it is? 1 by p minus z plus 3 minus 1 that is 2. So answer will be 90 degree. And when q is equal to 1, what will be your angle then? Angle will be 180 into 2 plus 1 divided by 3 minus 1 that is 2. So it will become 180 degree into 3 divided by 2. If we cancel this, it will become 90 degree, 90 degree that is 270 degree. So what are the angle of asymptotes is? So we have to write angle of asymptotes.
90 degree.
Angle of asymptotes is 90 degree and 270 degree. Okay, now you get the angle of asymptotes where the how the straight line's angle should be. Now where it start? That starting point is said to be centroid. So to find the centroid, what is the formula? To find out the centroid, the formula is
Sum of poles minus sum of zeros.
sum of poles minus
Sum of zeros.
sum of 0 zeros divided by
B minus
number of poles minus number of zeros. Okay, what is the sum of poles here? 0
0 plus
plus
minus
it will become minus 2 plus 2.64j. Next one is
minus 2
minus 26.4j. Okay, so minus sum of zeros. How many it is? 1 0 and 1 0 is minus 9. Divided by number of poles is 3, number of zeros is 1. Okay, so if you solve this, what will be getting? You can cancel this plus 2.64j and minus 2.64j. So it will become minus 2 minus 2 will become minus 4. Here minus 6 minus 2 will become plus 9 divided by 3 minus 1 is 2. So we will be getting 5 by 2. So 5 by 2 is 2.5. So what is our centroid? 2.5. Centroid is there in the real axis. In the real axis, what is represented as sigma. So the centroid is represented by the symbol sigma. Sigma is what? It is 2.5. Clear? And now in your graph sheet, what you have to do in the sigma, where the 2.5 comes? In the real axis, positive side. Over here, if it is 1 means, if it is 2 means, it will be in 2.5. Okay? So here is who is going to be centroid at 2.5. But wherever the locus lies from 0 to minus 9. There is one condition. Root locus will always exist between poles to any zeros or from a pole to infinite. Last class we have discussed the sum. There root locus lies everywhere from a
0 to minus 2.
pole to certain only pole. Okay, from a pole to infinite. That's how the root locus will be. It will not go away from that. But here, what is our centroid is 2.5. If I place the protractor over here, okay, what are the angle of asymptotes? 90 degree. So I have found the point where the asymptote should be. Now asymptote is a straight line. I am going to draw a straight line that is in a dotted line. It should be an angle of 90 degree. So if I place this point, the protractor over 90 degree is a straight line. Asymptote should be marked only in the dotted straight line. So 270 degree means this straight line is to be 180 degree, right? So 180 degree plus another 90 degree is what? So that is 270 degree. Okay. So this is 90 degree and this is also 180 plus 90 is 270. So this is how the angle of asymptotes at the centroid will be. In this problem, the root locus is lies from where to where? From this pole 0 down to go to 0 to minus 9. Here, root locus can only touch the angle of asymptote and can only touch the asymptote line. Okay, it won't cross the line. Okay, last we discussed the problem. There we have started from the asymptote, but here there is no relationship with this two. It just touch the always touch that asymptote. That's it. Okay, and now what you have to find out the next thing?
Find the breakaway and breaking.
Step 4. That is to find out the breakaway and breaking point. Okay. The breakaway and breaking point only when it exists means. Okay. That is also a condition. If it is the root locus is between two poles. If the root locus is between two poles. Okay. If there is a point over here, we are going to find the breakaway point. Okay. So if the root locus lies between two poles, by using a formula, breakaway point formula, we will be finding a point. That point is said to be breakaway. If two poles are there, what you have to find out? Breakaway point. That's it. Okay. And suppose Two zeros are there. Root locus lies between two zeros. Then we have to find out the break-in point. Okay, breakaway point is different, break-in point is different. In last problem, that is in the first problem, we have calculated the root locus only between the poles. That is 0 to -2, -4 to infinite. In that itself, we have find out that root locus lies between 0 to -2. 0 is also a pole, -2 is also a pole. That exists what? Breakaway point. That is last case, last problem case. But here in this problem, by applying this condition, root locus lies between where and where? Sorry, breakaway and breaking point should lies where? Breakaway point should lies between two poles. Breaking point should lies between two zeros. Okay, but in our root locus, how it is? Root locus is there existing between a pole and one zero. If it like this means there will be breakaway and breaking point. That's it. Okay, you have to write it down. Since our root locus lies between a 0 and a pole, there is no breakaway and no breaking point. Since it is like this, there is no breakaway and breaking point. Clear? Are you clear with this step 4? And next step 5, what is this?
Find
Step
crossing point.
Step 5, what is?
Crossing point on imaginary axis.
Now you have to find out the crossing point where it is crossing the imaginary axis. Okay, and for that, what we have to do that? We have to go for the closed loop transfer function. That is, you have to find out the characteristics equation. Okay, step 5 is finding the crossing point. Okay, and now for that, what is the thing we know that? Before that, one thing you have to note it down. When there is no poles, when there is no breakaway and breaking point. Okay, when there is no breakaway and breaking point, what we will be finding means. In our question, we have complex zeros or complex poles.
Complex poles.
Complex poles. Okay, there is no breakaway and breaking point. These two things you should keep in mind. We have in our problem there is complex poles, and our locus lies between a pole and a zero. So no breakaway and breaking point. So what I am going to do from the next step means, okay, from the breakaway and breaking point only we have found that the previous basic model. We have looked at the breakaway point only. We found what? We have drawn the curve where the crossing is going to come. We found out, right? From the breakaway point, next to what is our where the locus is going to cross. We found out, right? Here there is no breakaway, no breakaway. So what we have to do? We have to want some point to draw the root locus, right? For that, what we are going to calculate? We are going to find out the angle of departure. It is said here as what? Angle of departure, right? And it is the angle of departure. What does departure means? The starting place, right? So where the root locus is going to start, that we are going to find out. Okay, so since there is no breakaway and breaking point, what we are going to find out? Angle of departure. Why? In our question there is complex poles. Okay, so why we are finding this angle of departure? Because our system having complex poles. Mark my words. I am going to say that since complex poles we are calculating angle of departure. What if complex zeros is there? If numerator is x square plus 4s plus 11 is means, we will be finding out angle of arrival. Okay, so if in this problem we are going to solve that, but just note it as note if complex
Zero.
If all complex zeros is there, we will be finding out complex folds, angle of departure and negative formula. To find the angle of departure, what is the formula is that it is 180 is right, angle of departure is equal to 180 degree minus theta 1 plus theta 2 plus theta 3. For that, you have to know what is the theta 1, 2, 3. Okay. For that, what you have to do is you have to take this. Okay, copy of this. So, to find the angle of departure, okay, we have to know what is the theta 1, theta 2, theta 3. For that, you have to go to the graph, that is the availability of zeros as well as poles. Okay, the angle theta 1, where you have to eliminate this small poles and zeros. What is the angle between these two poles? Just to connect these two. Okay. Just draw a light shaded line to connect these two poles. Okay. Then, with respect to where I am drawing with respect to the CL axis, right? This is the angle theta 1. Okay. And likewise, the straight axis goes over here. And this is the reference line. They made this as a reference line and mark this angle. How much it will be? It is theta 2, which is will be equal to 90 degree. You can say that it is 90 degree. Okay. Now, the next, if it here it is pole. From this pole, okay, from this pole, connect this. Okay. So, with reference to the rear axis over here, and this is theta 3. Just take your protractor, place it over here. Okay, and mark this theta 1. It will be around 127 degree. If you do it will be around 127 degree. And here we know theta 2 is 90 degree. And here if you place the protractor over the pole, that is at the point minus 9. If you place a protractor over it will show you a degree, right? That is theta 3 is 21 degree. Okay, so if you do that in the graph sheet, you will achieve these 2 degrees, these 3 degrees. Then you have to substitute the angle of departure formula. What it is? 180 degree plus theta 1 plus theta 2. What it is?
1.
So minus right? Minus 127 degree plus theta 2 is 90 degree. Again plus theta 3 is 21 degree. When you are doing this, when you do this calculation, you will be achieving is minus 17 degree. And in this add this to 4 and add these two and